All right, so for 56, if you see evaluate, that means to find a value. Now, typically, it's not written in an equation form, but I like to put it in an equation form so I can change it to an exponential. Now, you could do this on the calculator if you wanted to do a change of base, since you're allowed to use the calculator on the entire exam, so you could just do that real quick. If you had to do this by hand, just to give you an example, changing this to what we call exponential form, the base of the log pushes that x up in the air to become an exponent. 36 is 6 squared. So here, if you can match the bases up, then the exponents have to be the same. So if you would evaluate this, the answer would be 2. If you had typed this into the calculator using the change of base, you would get the same. Remember, if the log doesn't have a little subscript base written in there for you, it's assumed to be base 10. That's the common logarithm. So to get rid of the log, only way to do that is to push this over into exponential form. Now, the little subscript, the base of the exponent, the base of the log becomes the base of the exponent. So this would be 10 squared. All right, so I got 3x plus 10 is equal to 100. And you can solve this in your sleep probably. We're going to subtract 10 and then divide by 3. So 30 would be my answer for that question. Okay, now, number 58 is tricky. You want to isolate this expression that has the 4 to the third power. So don't ever distribute to something with an exponent like that. You want to get everything away from that. So I'm going to add 5, and I'm also going to divide by 4, just kind of in the same step because I don't have a lot of space here. We would end up with 3 minus x to the 4/3 power. If I add 5, that's going to give me 64, and then if I divide by 4, that'll be 16. Okay, now what we want to do here to cancel out the rational exponent is use its reciprocal, because when you do a power to a power, you multiply the exponents, and if I do 4/3 times 3/4, that's equal to 1. That cancels out, and 3 minus x. Now, you can, of course, just do this on your calculator right now. I just want to remind you of one thing. So I'm going to change this into radical form just really quickly. And this would really be a 4th root of 16 to the 3rd. Now, the reason I'm making a deal about this is because if you take, which we are doing here, like a 4th root or a square root, or a 6th root, you have to remember that that has 2 answers, which would be plus or minus. So what we really have here, 3 minus x plus or minus. Okay, now of course you can do this in the calculator, but the 4th root of 16 is 2, and then 2 to the 3rd power is 8. So I have 3 minus x could be 8, or 3 minus x could be negative 8. Now, these are not the same answer, so be careful when you do this. It's not like the positive and negative of the same number. This would be x equals negative 5. Here I'm going to subtract the 3. Now I get negative x is negative 11, so 2 totally different numbers. X could be 11, or x could be negative 5. This has 2 answers to this question. For number 59, you want to isolate your radical, so I'm just going to add this 3 real quick. We have x plus 4 is equal to 9. To cancel out the square root, we're going to square both sides. And this is just going to give me x plus 4. This is going to give me 81. And then literally all we have to do there is subtract 4 from both sides. So 77 should be our answer. Okay, converge or diverge. So if a sequence, if the series converges, first of all, it has to be geometric. This can't happen if you have an arithmetic sequence. It has to be geometric. The R value, now I'm going to put this in absolute value, okay? So really the R value could be a positive number or a negative number as long as it is less than 1. Okay, now if you don't know how to find the common ratio, which is the R value, which is what you're multiplying by, like this is, let's say, our first term, our second term, third term, 4th term, from what we can see. If you take any term, I'm just going to take the second term, and divide it by the term before, that will give you the R value. So any term divided by the term before it. So if I do 1 over 24 divided by 1/6, I'm just going to do keep, change, flip. And this is 6 over 24. And when I write this, you guys could probably just tell this from looking at the equation, but you are multiplying by 1/4. This is the R value. And this would fit into this category. So this is a series that converges. Now, let me just show you really quickly here. When you find the sum of a series, you just start adding the terms together. So if I do 1/6 and I add to that 1 over 24, and we get this tiny decimal, and I add to that 1 divided by 96, you guys can hopefully see I'm barely adding anything, because as I keep going here, like if I do 1 divided by 384, that is a super tiny number. The next term in that would be 1 divided by 384 times 4, whatever that is. But the next term I add, this is so small, we've got like 10 to the negative 4th power. So as these keep going here, you have got teeny, teeny, tiny fractions. So it literally is like you are adding nothing. And that's why it actually converges to a sum. So if it has a sum, this has to be an infinite geometric. This is that first term over 1 minus the common ratio. This is on that formula sheet if you guys don't see it. Okay, your first term is 1/6, and your common ratio is 1/4. Now, recommendation, do 1/6, that's the first term, divided by, put this in parentheses, or this will not be correct. So 1 minus 1/4 or 0.25 or however you want to do it, but I need to divide 1/6 by the difference between those two numbers. If I don't put parentheses here around the 1 minus 1/4, what the calculator will do is divide 1/6 by 1 and then subtract 1/4 from that value, which will give you completely the wrong answer. Okay, so this is 0.2 repeating. I'm just going to hit my math button real quick to turn that into a fraction. I think that's how it's written on the answer key. So the sum here to infinity, this will approach 2/9. Okay, be real careful with number 61. It says you drop a tennis ball from the height of 9 feet. So you actually start with this tennis ball up in the air, and it rebounds 85% of its previous height. You want to find how high the ball will bounce on the third bounce. Okay, so I have 1, 2, 3, and this is not drawn great, but pretend these are the rebounds. Now, you can do this just by hand. So after the first bounce times 0.85, this would be 7.65. Times that by 0.85, it's about 6.5025 here. And then if I multiply that, this will be 5.527. You guys can see the decimal there. Okay, now here's the deal. You can also use the formula to find a term in a geometric series here, because each time we're multiplying by 0.85. The deal is that I think people get confused about, this is actually your first term as your starting place. Then you have 1, 2, 3 bounces. So this is the second term, this is the third term, and then after the third bounce is not the third term, it's actually the fourth term here. So if you did want to use a geometric explicit, you can do that here. You just have to be mindful that you are finding the fourth term, not the third term, because the fourth term would actually be after the third bounce. Now, this would be 4 minus 1. So I'll just show you guys on my calculator. You could do it by hand like I just did there, or if you do this, 4 minus 1 to the third power. And you can see I got the same number, just 2 different ways to do it. Okay, is this sequence geometric? If so, identify the common ratio. Geometric means I have to multiply by the same number between terms. Looks like here I'm multiplying by -5, -5, -5, so I would say yes, and R is going to be -5 here. Okay, Justine earned $17,000 during the first year of her job at City Hall. This is going to be a series question, And so the first term is going to be the amount she makes in her first year. After each year, she receives a 4% raise. Find her total earnings. Total, you want to think of the word sum. And then first 5 years on the job. So I want to find the sum of the first 5 terms here in this series. And the thing I want you to be mindful of, though, the common ratio here is going to be 1 plus 0.04. And let me show you real quick. So if I'm making $17,000 and I just multiply that by 0.04, I'm not making $680 the next year if I'm getting a 4% raise, but that's the amount I would actually add. If you multiply this by 1.04, the 1 accounts for what you already have, the $17,000, and then adds that 4% for you. So in her second year, she would make $17,680. So make sure you're just careful of that. So the R value is going to be 1.04. Now, this is geometric because I'm multiplying by a 4% or 1.04 every time. We're not adding the same thing. Now, the formula for this is the first term, 1 minus the common ratio to the n. N is going to be 5 here because it says the first 5 years, and then over 1 minus the common ratio. Now, we can type this all into the calculator just real quickly here. Don't have a lot of time. To the 5th. Now, I would just recommend, as I have on every question, if you do the denominator, put, this is a difference here, put that in parentheses, and she's going to earn $92,077. This is money, so I'm going to round to the nearest hundredth, 48 cents. Oops. There we go. Summation notation is the sigma. And what we want here, this is your first term, this is the last term, and this is the explicit formula for whatever you're working with. Here, I'm adding 2 each time, so this is going to be arithmetic. Okay, general form here for an arithmetic explicit, first term plus the common difference times n minus 1. Okay, 13 terms. I'm going to set this guy up. We're starting with the first term. I want the sum of the first 13 terms. So the 13 is going to go here. Now, I just need to write the explicit formula, and then we're golden. So when I look at this, my first term is 60. We're adding 2 every time. That's the common difference. Don't add these. You got to do the distributive property first here in your order of operation. So this will be 2n minus 2. So what you're going to see here, this will be 2n, 60 minus 2 is 58, and this is your summation notation. Now, 65, y varies directly with x and inversely with z. So y equals k times x, inverse is turning it into a fraction. Okay, now I'm going to sub some stuff in. They're going to give us just enough information that we can figure out the k. Don't forget the k. That's the constant of variation. Okay, so 10 is y. K, we don't know. X is 6, and z is 3. So we're just going to solve this real quick. I'm going to multiply both sides by 3 to get that out of the denominator. And then, sorry, there's not a lot of space here. Divide by 6, the k value is 5. Now, if you're supposed to write an equation, literally all you have to do, you're going to take what we just had originally over here, and you're just going to replace that k with the actual constant of variation. So here's what I want for the equation. This would be 5x over z. Done. Now, the questions typically then ask you to find something else. So it says find y when x is 8 and z is 4. So we're just subbing numbers again. So let's see. K value is 5 here, so I'm going to sub in 8 for x, 4 for z. 40 divided by 4 is going to be 10. So the other part of that answer is if x is 8 and z is 4, then y is going to be 10. Okay. Arithmetic, geometric, or neither. I'm obviously not adding the same thing between terms here. If you want to check for geometric, what you want to do is any term, I usually just do the first and the second. If you do any term divided by the term before it, so the second number in this list is 81, 243 is the first term. Alright, so if I do this, 81 divided by 243, math, I'm just going to turn this into a fraction. Okay, I get 1/3. So let's just check to see if this is legit. If I do 81 times 1/3, sweet, that's 27. If I do 27 times 1/3, just checking this a little bit, that's 9. If we do 9 times 1/3, we're doing 3, so we're in good shape. This is consistent. So the common ratio here is 1/3. You're dividing by 3 every time. It has to be what you're multiplying by, which is multiplying by 1/3. So this is geometric. Okay, now find the 10th term. You can use the recursive. I would recommend explicit because it's faster. So I just need the term number I want. I want the 10th term. So the first term is a sub 1, that's 243. And I'm multiplying by 1/3. And the n minus 1 here, if I want the 10th term, this would be 10 minus 1. Now, I'm just going to shove this into the calculator. So 243 times 1/3, and then just to save myself some time, 10 minus 1 is 9, so I'm just going to write to the 9th power there. Let me see if we can change this to a fraction real quick. So this is 1/81. That's the 10th term. Okay. Crud, we don't have a lot of space down here. Okay, let's factor some stuff. Alright, so x minus 3, this is the difference of squares, x minus 1, x plus 1. Okay, now, nothing's getting canceled here, so let's just leave this for a second. And we are doing some division, so let's just see if anything cancels here. So factors of -3 that add up to -2, we got to use a -3 and a +1. Okay, now in this fraction, we can actually get rid of that. And for the moment, I can't do anything else. This would leave a 1 on the top. And now, because I used the space over here, I'm actually going to come back over here just a little bit. Okay, I'm going to keep the original fraction where nothing canceled. And I'm going to change this guy to multiplication, and then we're going to multiply by the reciprocal. Now, all that's left here is this x plus 1, and then you could put the 1 on the bottom if you want, but you don't have to. All right, now, multiplying, these guys match, so they cancel out. Now, all that we have left here, write it in green so you can see it, x minus 3 is left on the top, x minus 1's on the bottom. Don't you dare be crossing those x's off, because anytime there's adding or subtracting, you can't just do that. You can only do that if you have factors. Now, in terms of restrictions, any place that the denominator could have been 0, even if it canceled out, we got to restrict that. So here's what's going on here. I have right here, if x was 1, that would be a problem. If x was -1, that would be a problem. Even though this canceled out, if x was 3, that would have made that a 0 denominator, which we can't have. -1 here would be a problem. We've already written that. And then when we flipped the fraction over, we'd already taken care of that x minus 3 there. So these are your restrictions. 1, -1, and 3. Okay, domain. If I'm doing a cube root function, this is going to be 3, 4, and in general, your cube root function looks like this. This point is opposite copy. That's going to tell you where the graph switches directions. So just a rough sketch would look like this. Okay, now for your domain, you're going left forever, right forever. Guess what? That's all real numbers. If you're into the inequality notation, this would be -infinity to infinity. Okay, changes to radical form, I call this bottom out. The bottom of the fraction becomes the root. You could also write this like that. Both of those are acceptable notation. Okay, explicit formula, we're subtracting 3 every time, a sub n, first term, common difference times n minus 1. This is explicit for an arithmetic, which is arithmetic because we're subtracting the same thing between the terms, I'm going to sub in the 20. We are subtracting 3, so I'm going to write this as minus 3 here. And don't subtract these. Distribute the 3 first. So you got minus 3n and then plus 3, negative 3n plus 23 would be an explicit formula. And then I got one more problem here. Just a little distributive property, square root of 24, square root of 18. Both of these break down. Biggest perfect square that goes into 24 is actually 4. And the biggest perfect square that goes into 18 is 9. Square root of 4 is 2, so this simplifies to be 2 roots of 6. Whoa, I'm sorry, I'm not on screen. This pull out a 3. Cannot do anything else here. These are not like radicals. That's your answer.